All companies store data. From a simple record book of a small business, maybe even on a journal or a piece of paper, to massive companies like Amazon that need computers to store petabytes of data. Now, in order to store this information, pretty much every company, and sometimes individuals too, need something called a database. We saw in the last section how hard it was to have our server remember a new user. Every time the server crashed, the variable would get reset and then it would start all over. Or if we wanted to do a login or a sign-in check and iterate through the emails and passwords, doing a loop through JavaScript, that's inefficient. That's where database come to the rescue. So let's ask ourselves, what is a database? A database is a collection of data. And what we mean by data, there are many forms of them, right? There can be numbers, there can be dates, there could be password hashes, there could be user information. Databases allow us to organize this data in a way that is useful to us. And it makes data management easy. And something came out of that. And it's called Database Management System, or DBMS for short. It's a collection of programs which allows us to access databases and work with data. And it also allows control access to database users. So a DBMS is something in this box. Something that allows us, a tool, a piece of software that allows us to communicate with the database, store information that's useful for us, and also allows us to update, insert, delete, look up whatever is in the database. And this idea of a DBMS really started to take shape in 1960s. And now it is at the forefront of many exciting things. There's an entire industry of engineers that just work with databases because it is so important. Now, there are two types of DBMS that are really popular right now and that we're going to talk about in this course. And these two types are represented really well by Postgres and MongoDB. Let's talk about the first one, which is relational database. And this is probably the most popular. As you can see on the right-hand side, you see that all of these are relational databases. Postgres, Oracle, SQL Server, you may have heard of MySQL, SQLite. These are all types of databases that have this relational database tag to them. And the beauty with them is that they're all pretty much similar. They all follow a same standard format. Relational databases consist of two or more tables with columns and rows. So in this case, users is a table, and full name, username, text created at are columns, and whatever values they have here are rows. Each row represents an entry, and each column sorts a very specific type of information, like name, address, or phone numbers. And then the relation between tables and fields is called a schema. In a relational database, the schema must be clearly defined before any information can be added. And if this is confusing right now, don't worry, we're actually going to create these databases so it makes sense to you. If we had Twitter, for example, you can see over here the types of tables that we would have and how we would organize it. We would have a users table, a tweets table, a following table. And we can connect all these information, for example, by connecting different pieces of the table. For example, the username will be the same in the users table as it is in the tweets table. That way, we can say that the username in the tweets table is the foreign key of the username in the users table. And then from user will be the foreign key of username in the following table. Now, things like full name or ID, something that identifies each row in a table, is called a primary key. And we'll go through that later on in this section. All right, so all these databases, we're going to learn about PostgreSQL, but they're all pretty much the same. So once you know one, it's fairly easy to pick up the other ones. How do they actually communicate with a server, with the backend? Well, all relational databases use something called SQL. And SQL allows us to communicate, just like HTTP did, between the front end and the back end. With SQL, we're able to communicate with the database and modify or get or update however we want. And we'll have a video on this topic as well. All right, so that's relational databases. What about the second type? The second type is called a non-relational database or a NoSQL database. And once again, there are many, many different types of databases with some cool names like CouchDB and Hypertable. Now, a MongoDB or a non-relational database lets you build an application without having to define the schema first, unlike a relational database. If we go back to relational database, this schema or these tables have to kind of be predefined, right? We need to know how our app is going to look, make these tables so that once the app is public, we can start entering user information and tweets and followers. With a NoSQL or non-relational database, we can just define it as we go. And they all have different ways of storing this information. So each one is very, very different. And this is another powerful reason to use a non-relational database is that if your data requirements aren't clear at the outset of your project, and maybe you have a massive amount of unstructured data, you may not have the luxury of developing a relational database with a clearly defined schema. They offer instead a greater flexibility in that a non-relational database are more like folders, just assembling related information of all types. Now, MongoDB is something called document-oriented. It stores information as documents. Let me illustrate this point to you. I have my desktop here with two folders. One is a relational database, and here I have users, tweets, profile, following. And you can think of relational databases with this type of storage, where this folder lives somewhere on a computer that stores this information. And anytime we need to ask a database for something, well, we grab the users. And if we also want to grab the tweets of the user, we find the user that we're interested in, then find the tweets of the user that we're also interested in with the foreign key that links to the users. And we can also find however many followers that user has. We grab that information and display it on our web app. MongoDB, on the other hand, will actually have each user as a document. So if I wanted to grab the first user, well, I just grab this document and it has all the followers, the tweets, the profile, everything is in this one document. And you might be thinking, MongoDB looks like a better choice than having this way of doing things, right? Well, it depends on your need. And that's why databases is such a complex topic. It really, really depends on your situation. You can see this MongoDB way being very useful if you had something like a profile, maybe a LinkedIn profile. But if you needed something where you're working with just following data or just tweets data, maybe with the tweets, you want to see what is the average tweet size. Well, it's really easy to just grab this file and calculate that versus this way where you might have to extract it from each one of the users. So it really depends on your needs. Let me show you another diagram that might be useful. When we look at relational versus non-relational databases, you can think of relational as each table has a blog post, a blog tag, a blog comment, and it links these tables to give you the blog information. Versus a non-relational that stores this entire blog post in an entry and has comments, tags, categories, and all other related data just in one single place. So what does MongoDB use to communicate? If we go back to our example here, we had SQL for relational databases such as Postgres. Well, MongoDB has its own what we call query language. And it is just the MongoDB query language. But they both aim to do the same thing. That is to communicate with the database, provide an easy way for the server to communicate with the database. And in this section, we're going to be talking about that. And we're going to finally connect the dots and show you the power of databases once they're connected to a server. I'll see you in the next one. Bye-bye.